Alright, so you've had a couple minutes to look at that. I'm going to ask Mikkel, Allie, Chloe, and Josh Wood. Tell me something about it. So Mikkel, you can choose what it is. Tell me something about this graph.
So, first of all, the degrees, one degree of the numerator is 1, the degree of the denominator is 2, so just like our last problem, our horizontal asymptote is 0.
Nice job. Great, thanks Mikkel. So then let's go to Allie. Tell me something else.
The x-intercept is 1, so the numerator is set equal to 0, and then, sorry, I'm running out of different
Yep, there you go. So we set the numerator to 0 and solved. Or we got an x-intercept of -2. So let me draw those in. So here's our horizontal asymptote. And then we got an x-intercept at -2. Now this is, sorry, let me back up. I didn't really explain this well before. We're used to saying that with horizontal asymptotes that you can't cross those. We're actually, that's why we call them end behavior asymptotes. It's what we approach on the ends. If we're near the origin, we're going to cross those occasionally. Only the horizontal or slant. But we'll never cross the vertical asymptotes, okay? Okay, so we have x-intercept, horizontal asymptote there. Chloe, give me something else. How'd you do that? You would. Good job. Okay, keep going. What does that tell you what can we not let x be?
0.
Awesome. And so that's going to become what? Your vertical asymptotes. Good job. So at x equals 0, and at -4, whoa, what happened there? Okay, there we go. There's our vertical asymptotes. Okay, so then, Josh, what about our y-intercept?
So you sub it off for 0.
Uh-huh.
And then you get 2 over.
You get 2 over 0. What happens when we divide by 0? Nothing good. Is it 0? No. If you look at this, we actually have a vertical asymptote at 0. So are we going to have anything going on there? Nope. So if you plug in 0 and it gives you 0 in the bottom, then you just put a little dash here and say, yeah, nothing's going on there, okay? Awesome. Okay, now pause. Were you guys able to get this far? Or figure out most of this? Do you have any questions? So now, let's go through. I'm going to create the sign array. Remember this, the sign array is going to tell us when this can change from positive to negative. So one place it could is at -4, that's our vertical asymptote. At -2, that's our x-intercept. And at 0, that is our vertical asymptote. So to kind of start this off, I just need to plug in a number and figure out whether that's positive or negative. So, hey, Brenda, why don't you choose a number for us? 3?
Yeah.
Okay, sure. We just need a number bigger than 0, so you want to do 3?
Or we just 2.
Okay, let's do 2. So I'm going to plug in 2. Go back to the beginning. And I'm going to kind of do this up here. When I plug in 2. 2 plus 2 is 4. Then I'm going to get 2 squared, that's 4. Plus 4 times 2, which is 8. So that gives me 4 over 12, which is 1/3. So when x is 2, y is 1/3. Now, what does that tell us, guys? What was the whole point of plugging in that point? Knowing that for this range, it's going to be positive. So now I'm going to come down here and go. Okay, that's what that looks like. Now, could I go back and plug in all these other points? Sure, but I'm starting to see a pattern here. If it was positive here, what's it going to be for the next interval? Negative, because it was going up on one side, then on the other side it's going down. Hey, this x-intercept, did it have a multiplicity of 2? Nope, so it's gonna bounce or cross? So if it was negative here, it's gonna cross to become positive. Which means, what shape am I making right there? S curve. If it's positive right here, what's going on the other side? It's negative. So guys, what we're doing here is we're starting to see a pattern that it's going to look like this. Now, if you're like, I don't get what you're saying with the vertical asymptotes, could you plug in points for all those intervals and get a positive or negative? Yes. I don't really like to do that. Now, how can you check you did it right? Desmos, hurry and graph it. I'll give you 30 seconds. Graph it. Question, yes. Okay, so the way you get your y-intercept is you plug in 0. But if I plug in 0 here, I'm going to get 2 over 0. What's 2 divided by 0? Undefined, exactly. That's how we know nothing's going on. Good question. Alright, did you guys graph it? Does it work? I know some people are just, I just started typing. Oh, I'm so anxious about the next one. Yes. So your option for that is it's going to be above, it's going to be below. So it's positive. Yeah, I mean, you could plug in, like, for example, you know, at 2 it's going to be a 1/3, so I did draw a dot at 2 1/3, but I'm not going to be too picky as long as you go from one to the other. Alright, let's go to the next one now. And we're going to do the same thing that we did before. Alright, so this one's going to be a little bit different. But let's walk through this, okay? So, number 1, we want to figure out the end behavior asymptote. Okay? Let's call on some helpers here for this. Ofa, how do I figure out the end behavior asymptote? We do, and what is the degree of your numerator? What's the degree of your denominator? So what do we do if our degrees are the same? There we go. If you're looking at number 2, if n equals m, horizontal asymptote of the quotient of the leading coefficients. I have a 2. What's my leading coefficient there? 1, right? If it's not right, it's 1. So my horizontal asymptote is going to be at the line y equals 2 over 1, or just 2. So I'm going to go to my graph here, and at 2, I'm going to just, like that. Alright, thanks, Ofa. Step 2, Mapu, how am I going to get the vertical asymptotes? Okay, we're going to get it from whatever makes the bottom become 0. The denominator. Which means we need to factor this. So x squared minus 4, it's a difference of squares. You know what that would factor to? Perfect. X plus 2, x minus 2. So what would make that become 0? Awesome. And that's going to turn into our vertical asymptote. So x equals negative 2 and x equals positive 2. Those are going to become vertical asymptotes on a graph. So I'm going to go to 2, put a vertical line, and negative 2, put a vertical line as well. Great. Let's now go to Christian. Christian, where do we get the x-intercepts from? That would be if we didn't have that leading coefficient or anything, that would be it. But you know what we're actually going to need to do is factor the numerator as well. Now, on the last one I gave you a clue. What's our first step? We always look for when we're factoring. Always look for the what? GCF, greatest common factor. Christian, what would that be on the numerator there? So I'm going to factor out a 2. And when I do, that leaves behind x squared minus 1. Well, Mapu factored x squared minus 1 is x squared minus 4 is x plus 2x minus 2. What would x squared minus 1 factor to? X plus 1x minus 1, right? It's a difference of squares again. Which tells me I want to know when this is going to equal 0, and it would be what two values? Say it louder, Brandon. There we go. So I have an x-intercept at -1 and at +1. So I'm going to go on my graph to 1 and -1. And those are going to be my points. Okay, now let's go to tau. What about the y-intercept? Good, plug in 0. I'm going to cover up my x's because they're gone now. What's left? Which would become? Nice job. So I've got a y-intercept at 1/2. Now, it's kind of like connect the dots. No, what I do? Oh. Why? It said it's shutting down. Oh, don't shut down. Cancel. Yes. I don't even know what button I put. That was close. Okay, hold on. I'm saving. I'm going to pull this up real quick. It disconnected, but we're good. Maybe. I might have to go connect it. Alright, so guys, what I want you to do is try to visualize, look at your graph, what's going on there, okay? Can you see what this is going to look like, or do you need to do a sine array? Yes. Alright, we're back. Guys, what's going on in the middle? In between the vertical asymptotes, what shape are we going to see? It's a U shape, right? Can you see how this is going to be like a flipped U? That's a connect the dots kind of thing. So I'm going to go ahead and I'm going to graph that. Connect the dots. Okay, now if the graph is going down on this side of the vertical asymptote, what's happening on the other side? It's going up, so I'm going to start it up at infinity. Same with the other side. See how it's coming down? That means on the other side, we're going to be up at positive infinity. So now this one I was able to do without doing a sine array. Now if you're like, I still don't get how you knew it was there, you could still do a sine array, but now instead of saying is it positive or negative, you've got to say, is it higher than 2 or below 2? Now, there's another reason why I know this graph wasn't going like this. If it was going down, it would have to cross the x-axis, which would mean we would have an x-intercept. Is there an x-intercept right here? Nope, so that means it's above it. Okay, will you check this real quick? Get back on the Desmos. Make sure you're careful with your parentheses here. Well, let's see if it matches what you got. Do one more. This is going to be yours. Now, it looks a little scary, but just remember a couple of things. What did we say about factoring? What do you always look for first? Greatest common factor. That's your clue. Let me give you about 2 minutes to start this, and then I'm going to come join you for the last bit, okay?